Hi, in this video I will explain the rules for naming alkyl halides. Alkyl halides are organic compounds that have at least one carbon halogen bond. Whenever we have a bond between carbon and one of the halogens, which are fluorine, chlorine, bromine, or iodine, then the compound will belong to the family of alkyl halides or organohalogen compounds. But how do we name alkyl halides? We can either name them by starting with the name of the alkyl group followed by the halogen, such as in this case we have one carbon, so this is methyl, and we have iodine, so this is methyl iodide. Or in this case we have two carbons, so this is ethyl, and we have bromine, so this is ethyl bromide. Or here we have, this is a propyl group, this is propyl, and then we have chlorine, propyl chloride. Or this is an isopropyl group, this is isopropyl fluoride. However, this method is difficult to use if the structure of the alkyl halide is more complicated, and that's why we mainly use the IUPAC naming rules for naming alkyl halides. And according to the IUPAC naming rules, the halogen will be named as a halo group. So for example, chloro, bromo, iodo, or fluoro, and then these usually are given the same priority as alkyl groups. For example, in this case, so we will name this compound as an alkane. This is 1, 2, 3, 4, 5, 6. So this is hexane. And then we have bromine, which is now as a branch. This is bromo, hexane, and we have to try to give the bromine the smallest possible number by counting from the right side. The bromine will be at position 3. So this is 3-bromo hexane. In this case here, again, we have 1, 2, 3, 4, 5, 6. So this is the longest chain, and this is hexane. We have bromine and chlorine. They should be written in the alphabetical order. So bromine goes first, bromo, and then we have chloro here. Now we have to put the numbers. Again, it looks like counting from the right side will give the smallest possible numbers to the halogens, and that's why this is 3-bromo, 2-chloro, hexane. If we have two similar groups, then we will use the prefixes such as di, tri, or tetra. This is again hexane. And then we have 2 chlorine, so this is dichloro, hexane. And then the numbers will be 2 and 3, 2, 3, dichloro, hexane. Now we have an alkyl group and we have a chlorine. The longest chain is 1, 2, 3, 4, 5, 6, 7, 8. So this is octane. Chlorine will be written first because it starts with the letter C, and then we have the methyl group here. Again, we have to try to give our branches the smallest possible numbers, and it is clear that we have to start counting from the right side. So this is 3, and this is 4, 4 chloro, 3 methyl, octane. Finally, in this case here, 1, 2, 3, 4, 5, 6. So this is hexane, and the branches are ethyl and fluoro. Now, counting from the left side will give fluorine position 3 and the ethyl position 4. Counting from the right side will reverse the numbers, but they will be still the same, so 3 again and 4. Since we are getting the same numbers by counting from the left or right side, in this case we have to refer to the alphabetical order rule, which states that the group which is written first according to alphabetical order should be given the smallest possible number. Since ethyl is written first, then ethyl will be given position 3 and fluorine will be given position 4. So there is no priority for halogens over alkyl groups. They both have the same priority, so you have to give them the smallest possible numbers, or if you get the same numbers, then you have to use the alphabetical order rule. Let's try to answer this question. Of course, you can stop the video to answer it and then check your answer, or you can keep watching. So 1, 2, 3, 4. I have to go up because this is the longest chain. 5, 6. So this is hexane. So those are the two possible choices. And then let's start counting from the left side. 1, 2, my branches will be at 3 and 4. Or if I start counting from the right side, they will be 1, 2, again 3 and 4. So again, we have the same numbers. That's why we have to refer to the alphabetical order rule. In this case, bromine is written first, followed by the methyl. So bromine should be given the smallest possible number, and that's why the correct numbering will be 3 for bromine and 4 for methyl group. And that's why the correct name will be 3-bromo 4-methyl hexane. So this is the correct choice. Now, if we have chiral centers, then we have to include the stereochemistry or the absolute configuration of the chiral center in the name. For example, in this case here, first of all, let's name it 1, 2, 3, 4, 5, 6. So this is hexane. And then we have a bromine. So this is bromohexane. And bromine is at position 3. This is 3-bromohexane. Now we have to include the stereochemistry, so we have to assign the absolute configuration. And of course, this is 1, this is 4, 2, 3. So moving 1, 2, 3, we're moving clockwise. This is R, and that's why you have to put 3R between parentheses before the name. And this is how I include stereochemistry in name. Let's take another example. In this case, we have two chiral centers, but let's first name the compound. 1, 2, 3, 4, 5, 6. So this is again hexane. And then we have bromo and chloro. So bromo goes first, then chloro. We have to include the numbers, and it's clear that this is 2 and this is 3. So this is 3-bromo, 2-chloro. Now we have to include the stereochemistry, and the stereochemistry at the bromine will be R. And the stereochemistry at the chlorine will be R, but we will reverse it to S because 4 is not in the back. So the stereochemistry is 2S, 3R, 3-bromo, 2-chlorohexane. So you have to start with the smaller number and then the larger number. In this case here, 1, 2, 3, 4, 5, 6. So this is again hexane. And then we have 2-fluoro, 3-methyl hexane. We have to include the stereochemistry again at this chiral center here. The stereochemistry will be R, and at this chiral center here, the stereochemistry will be also R. So this is RR, and that's why this is 2R, 3R, 2-fluoro, 3-methyl hexane. If we have a cyclic alkyl halide and just have one branch, then this branch will be definitely at position 1. So this is a bromo cyclohexane, and bromine will be at position 1. Here we have a cyclopentane, and we have dichloro and ethyl. So dichloro starts with C and it goes first. So this is dichloro. And then we have ethyl group. Now regarding numbering, if I started from this position, the numbers will be 1, 1, and 3 for the ethyl. If I start from here, the numbers will be 1, 3, 3. So definitely this is going to be the correct one. So this is 1,1-dichloro 3-ethyl cyclopentane. In this case, we have chiral centers. This is cyclohexane, so this is cyclohexane. We have a bromine and chlorine. This is bromo, and this is chloro. Regarding numbering, if I started from here, this is going to be 1, 3. If I start counting from this side, it will be 1, 3. So, and since I'm getting the same numbers, then I have to use the alphabetical order rule, which means that bromine will get the smaller number and chlorine will get the other one. So this is 1 bromo, 3 chloro, cyclohexane. Now we have to include the stereochemistry. Again, the stereochemistry at this carbon here, bromine will be number 1, and this branch will be number 2, and this is number 3. So this is S. So this is 1S. And at this carbon here, chlorine will be number 1. This branch will be number 2. This branch will be number 3. This is R, but again, 4 is not on the back, so we have to invert the configuration. So this is going to be also S. So 1S, 3S, dash, and then you continue the name. Finally, in this case here, we have a tertiary butyl group, and then we have a bromo group, and this is cyclopentane. So this is cyclopentane. Tertiary butyl starts with B, and bromine or bromo starts with B. However, R, so in bromo we have BR, whereas in butyl we have BU. So this goes first, and that's why bromo will be here. Bromo, T-butyl, cyclohexane. Of course, you have to include the numbers. Again, 1, 2 in both cases, so we will follow the alphabetical order: 1 bromo, 2 tertiary butyl, cyclopentane. So this is how we name alkyl halides. Finally, let's check our understanding by trying to name this compound. So this is a cyclohexane for sure, and then the branches are bromo, chloro, and pay attention to alphabetical order, and ethyl. So B for first, Cl second, and then ethyl is the last one. Regarding numbering, if you start counting from here, the numbers will be 1, 3, 4. This is one option. And then if I start counting from the ethyl group, the numbers, if I start counting from here, the numbers will be 1, 2, and 4. So first set is 1, 3, 4. The other option is 1, 2, 4. And then one more option is if I start counting from chlorine, this is going to be 1, ethyl will be 2, and then bromine will be 5. So definitely the smallest set of numbers is this 1, 2, 4. So 1 goes for ethyl, 2 goes for chloro, and then 4 goes for bromo. However, it looks like this choice, in this choice, the alphabetical order is not correct. So the correct name will in reality be 4 bromo, 2 chloro, 1 ethyl, cyclohexane. So none of these choices is correct because here they have a problem with the alphabetical order, and in this case, in these two cases, the numbers are incorrect.